Hi friends, let's learn the equations of motion by tossing the ball and observing its motion. Since it's happening really fast, it's much easier to observe the motion of the ball in slow motion mode. Most of the smartphones today have a slow motion recording option. So you can try this yourself. Just toss the ball and record the video in slow motion mode. Now it becomes a bit difficult, to handle both of these. So you can give the phone to your parents or your friends and ask them to record it for you. I'm going to give it to my friend here and he's going to help me record it in slow motion. I'll make these equations really simple for you. I'm sure by the end of this video, you'll find it much easier to solve the sums based on these equations. And as usual, we'll finish off with our top 3 questions on this topic. When we toss the ball, there are 2 types of motion here, an upward motion and a downward motion. As we'll see in this video, they are different. So we'll split this motion into 2 parts, the upward and downward motion, and look at each separately. Let's start with the downward motion first. I'm going to drop this ball and I'll ask my friend here to record it in slow motion as well. So after this, we'll replay it in slow motion for you. Now I want you to carefully watch and tell me what do you think is the speed of the ball at the top, so at the starting position, and at the bottom when it's leaving your screen. So are you ready? Start. Now let's watch the slow motion replay. Watch carefully for the speed of the ball at the top and at the bottom. Let's analyze the slow motion video. So I'll replay it one more time for you. What is the speed of the ball at the top? That's right, 0. If you look carefully, it moves very slowly in the beginning. So the ball is starting from rest. The speed at the start is called the initial speed or the initial velocity. Now let's analyze the slow motion video for the speed of the ball at the bottom. Watch carefully. What is the speed of the ball at the bottom here? Is it 0? No, it's gained some speed by now. If you look carefully, it looks blurred here compared to when it was at the top. It looks blurry because of its motion, since it has some speed. If you hold your hand here, you can feel the speed. The speed at the end is called the final speed or the final velocity. It's hard to estimate the final velocity just by looking at it. So let's see if we can use the equations of motion to calculate it. Let's look at the 3 equations of motion. V equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as. Now what do these symbols mean? These are symbols in physics having a special meaning. Let me explain with an example. Let's say when I drop the ball, u stands for the initial velocity or the initial speed of the ball. V is the final velocity or the final speed of the ball here. T is the time taken by the ball during its motion. So that can be measured with a stopwatch. A stands for the acceleration of the ball. So what does acceleration mean? That's right, the rate of increase of velocity of the body here. And S stands for displacement or the distance covered by the ball during its motion. Now the term S is very confusing because when we hear S, usually we think of speed. But remember, S stands for displacement. An important exam tip is that usually in the sums, the terms speed and velocity are used interchangeably, and so are distance and displacement. But numerically, these mean the same thing because they are just scalar and vector pairs of each other. So when can we apply these equations? Can you use it for any moving body? What do you think? The answer is no. These equations work for uniformly accelerated motion or uniform retardation. Now, what do these terms mean? Uniform acceleration means the body is increasing its speed at a uniform rate. And uniform retardation means the body is losing speed at a uniform rate. We'll look at some of these examples in the video later on. But let's say the body is moving at a constant speed or a constant velocity. Then you don't need these fancy equations. As you may already know, you can use the simple equations. That is, distance equals speed into time, or displacement equals velocity into time. Let's place the three equations of motion we have learned so far on our concept board. Let's say we drop the ball and we want to calculate the final velocity after 1 second. So let's see if we can use the first equation of motion here, which is v equal to u plus at. So u here, the initial velocity, is 0. T is 1 second. And we want to find out v. But we need a, which is the acceleration here. So do you think the ball is accelerating? Let's take a look. The initial velocity is 0. But once it's falling, it has gained some speed. So the ball is certainly accelerating here because its speed is increasing. Now, who do you think is accelerating the ball here? That's right. It's Earth's gravity. So we can use the typical value of acceleration due to gravity, which is 10 meters per second square. And an important thing to remember is that during free fall, no matter how heavy the body is, everything accelerates with the same value, which is roughly 10 meters per second square. So let's plug in those values into the equation and we get the final velocity v as 10 meters per second. Let's say we want to calculate the distance or the displacement of the ball after 1 second. Now, which equation should we use? So one simple trick I can show you is that you write down all the three equations and go ahead and circle your unknown variable, which is s in this case. Now we know that u is 0 meter per second, the time we are looking at is 1 second, and a is 10 meters per second square. So we know u, a and t. So we can use the second equation of motion here, which is s equal to ut plus half at square. Now if you plug in the values into that equation, we get s, which is the displacement, is 5 meters. Now let's look at the upward motion. So I'm going to throw the ball upwards and you watch carefully and tell me what do you think is the speed at the start. So when it's just left my hand, and what is the speed at the top? I'm going to stop the video once the ball reaches the top because we are not interested in the downward motion here. And once again, my friend here will record it in slow motion so that we can watch it in slow motion as well. So are you ready? Let's start then. Now let's watch the slow motion replay. And you watch carefully and tell me what do you think is the speed at the start here and then at the top. Let's analyze the slow motion replay. So what is the initial velocity when the ball leaves my hand? It's not zero, since I'm applying a force on the ball. So I'm giving it a speed. And as you can see, the ball looks blurry. It's hazy due to its motion. So the initial velocity is greater than zero. Now let's focus on the final velocity at the top. So what do you think it is? That's right, it's zero. The ball comes to a momentary stop. And as you can see, the picture of the ball is clear. It is not blurred. So its final velocity is zero. So is the ball accelerating during its upward motion? What do you think? So it had an initial velocity here when it left my hand, and the final velocity at the top is zero. So clearly the velocity or the speed of the ball is decreasing. So this is a case of retardation or negative acceleration. And what's the value of A? It's going to be minus 10 meters per second square. So an important exam tip is, for downward motion, A is plus 10 meters per second square. And for upward motion, A is minus 10 meters per second square. Let's say I'm throwing the ball upwards here, and it takes 1 second to reach its maximum height. So how can we calculate the initial velocity that I'm giving it here? So U is our unknown. And what do we know? We know that the time is 1 second. A here is minus 10 meters per second square since it is upward motion. And what's the final velocity? V is 0 at the top. So we can use the first equation of motion here, V equal to U plus AT. Now substituting the values and solving the equation, we get U, which is the initial velocity, is 10 meters per second. Let's say I throw the ball upwards with an initial velocity of 5 meters per second. And we are interested in the final velocity after the ball has traveled a distance of 1 meter. So V is the unknown here. And what do we know? U is 5 meters per second, A is minus 10 meters per second square, and S is 1 meter. So we can use the third equation of motion here, V square equal to U square plus 2AS. Now plugging in the values, and once we solve the equation, we get V equals root of 5. So that's 2.24 meter per second. So as expected, the final velocity is lesser than the initial velocity because the upward motion is a case of retardation. Let's summarize our discussion. For downward motion, initial velocity is 0. For upward motion, initial velocity is greater than 0. Final velocity is greater than 0. Final velocity is equal to 0. Acceleration is plus 10 meters per second square. Acceleration is minus 10 meters per second square. And displacement is downwards. And the displacement is upwards. Let's put the comparison of downward and upward motion on our concept board. Now that we are done with the equations of motion, are you ready for the top 3 test-oriented questions on this topic? Coming up in a moment. Friends, hit the pause button right now and try solving these questions. Can we make this more interactive than just watching the video? So I would like you to write your answers in the comments below. Or if you have any doubts or feedback, feel free to post it in the comments below. I promise to answer all of them as soon as possible. So I'm waiting to hear from you, and I'll disappear so that you can solve these questions. Now an interesting question is, what will happen if I throw this ball, but there's no gravity here? What do you think is going to happen? So let's try it out. There's no gravity, and I'm going to toss this ball. Oops, it's gone. I guess then I'm done with the video. And do remember to like, comment, and share this video, and go hit subscribe for my channel. Thanks for watching.